Okay, so in my previous lecture, I talked about scalarization in general, and the type of functional that I used was Gershwitz functional. I mean, the functional which is related to the problem of Pascoletti-Serafini, which is, the functional was, for example, psi is equal to infimum of all t, where a plus ty tr minus y is inside the cone, but for any y is inside objective space. But here in this lecture I will talk about some more general kind functionals such as theta, eta, gamma, and psi. So because they have much better properties, and so again we assume that our set valued function is we use it from BP cones. So we find a functional L here, and then we create the set valued cone. So the interesting property of these functionals is that we can characterize them by minimizing them. So for example, if y bar is a strongly non-dominated element of A, then y bar is a minimal solution. So if we minimize that, then this one is 0. If we evaluate that at y bar. And many different parts as well, such as B and C, which uses a different functional. And so we want to prove each of them. The first one, A, says that, as I said, if y bar is a strongly non-dominated element of A, it means that y bar minus y bar is inside the cone. And our cone is defined by BP cone. Remember, BP cone is exactly this. And if we just use, so instead of u, we write y minus y bar, because y minus y bar belongs to this set. So we can write u as this one. And because if we write this like that, then this is just the definition of, gamma. So minus y bar, this is just a definition of the gamma functional, which is acting on y. So because this is greater than equal to 0, this can be written as gamma y bar evaluated by y bar, because if we just put y is equal to y bar, this one becomes 0, this one becomes 0, and the whole thing becomes 0. So that's why the functional becomes 0 at points where it is a strongly non-dominated element. The same similar analogy could be used for part B. Here, the definition of non-dominated element is just this. This is the definition of that. It means that if you write that, you can write that so there you cannot find any point which is less than or equal to L of y bar minus y. You cannot find, it means this equation, and this is equivalent to this one, so it becomes greater than that. And then if you just substitute and reformulate that, you can say that again you need to minimize this functional, but here instead of eta we use psi, another functional. A similar argument about part C can be used. So we just use the definition of weakly non-dominated element, which is this one, weakly non-dominated element. And we use and we substitute, and we understand that we need to minimize this functional as well. So all of them are about minimizing the functional, just like what I was talking about in my previous lecture, that I was minimizing the Pascaletti-Serafini functional. And so example could be, you could use this functional as well. The L as the, and A is as a subset of objective space, and you can calculate and figure out if a point is non-dominated or not. So the interesting thing is that if everything about these functionals, we have 4 functionals, everything about them is related to properties on L. So if L is continuous, then all of these 4 functionals are continuous. If L is lower continuous, then all of these 4 are lower continuous. If L is Lipschitz, then all of these 4 functionals are Lipschitz. If L is linear monotone, then all of them are just convex. All of these functional are convex. So you just need to care about this L, and everything is then could be understood for functionals as well. So we have, for example, if A is a subset of Y and L is Lipschitz, now in this theorem we are using the Lipschitz properties of L. Because if it is Lipschitz, then we can say if the induced norm of L of Y is greater than 1, then A has a weakly non-dominated element with respect to D. Here we use just the definition of C, and here we use the Lipschitz rank of L, and we can see that this is greater than equal to 0. So we use the result that I was talking about in theorem 6.1 to say that it is a weakly non-dominated element. And this is an example of L, which has a rank 0.5, and so L is 0.5. And we could conclude that, for example, 0 is a non-dominated element with respect to D. Because if we put that, it becomes 0.